this. The line drawn from the center of a circle that bisects a chord is perpendicular to the chord. The angle subtended by an arc at the center of the circle is double the size of the angle subtended by the same arc on the circle. Angles subtended by a chord of the circle on the same side of the chord are equal.
Germ Busters! Always remember, when you touch objects in public, hand washing busts germs.
Want to catch up on some of your studies? Join Mindset for late night studies. Monday is mathematics, Tuesday is physical sciences, with life sciences on Wednesday and accounting on Thursday. Friday is English, maths literacy on Saturday, and Sunday is a good day to catch up on geography. Every day from 9 p.m. till midnight, and again from midnight till 6 a.m. Late night studies, only on Mindset.
Did you know that bats are the only mammals that can fly? Other mammals are said to fly, flying squirrels for example, but in each case they are actually only gliding. The bat is the only mammal that achieves true flight. Bats do not flap their entire forelimbs as birds do. Instead, they flap their spread out digits, which are covered with a thin membrane.
No one ever asks why we do the weird things we do. Like, why once is never enough. Or doing 2 trips is just one too many. Why do we, before we use these, or say 5 when we mean 20? Why do we have second thoughts? And think that lift buttons make them go faster? Why don't we walk there? Cross our fingers, touch wood, and struggle to hide our true feelings. At Liberty, we want to know all the weird and wonderful things that make us human, because human beings, being human, are what we make financial solutions for. Liberty, in it with you.
Sanibonani Dumelang, hello and welcome to Tenfold Live. I am your host, Uspiro Matebula, and today we have another awesome episode lined up just for you. But before we get into the gist of things, I just want to send a big shout out to our sponsors, Liberty. Thank you so much for making all of this possible. Thank you, thank you, thank you. So guys, remember, we are an interactive show, so we want you guys to connect with us all the time. So connect with us on all our social media platforms. We are available on our app. It's called Tenfold Education. Download it if you don't have it. It's available on iOS. It's available on Play Store, so you have no excuse. Just download it. We're also available on WhatsApp. Just text our bot, Dex. He's called Dex, so you text him, and then he's going to answer all your questions. You can even send a picture of your question, and he will answer it. And then you can also live stream on YouTube, guys. Don't be scared. Live stream. Tell your friends to live stream. Tell their friends to live stream. Don't be scared, guys. This show is for you, and we are here to help you. Talk about help. You guys need help today with physics. Guess who's going to help you guys? It's Jacques. Jacques, over to you, sir.
Thank you, Supiwe. That was a beautiful, warm welcome. What a nice, fresh face to see on television. Supiwe, welcome to the team. Guys, as usual, we're doing second paper work. We are busy with question 9. By the way, you heard, I'm Jacques Duplessis, so you're going to spend the hour with me. Okay, so we are going to finish our question 9. And then that mainly works with a mixture of grade 11 and grade 12 geometry. And then our question 10 of our geometry paper also consists of a mixture of grade 11 and grade 12 geometry. So quite exciting work we're going to look at. It is geometry, folks. I teach geometry in a specific way, so I want you to look at what it is that we're doing and how we do it, folks. If you do the same, I guarantee you your geometry journey is going to be a pleasure. Okay, so let us see. We're going to start. Make sure when you write your geometry, you have color pens with you where you can mark angles that are the same. And also highlighters, possibly for sides. Okay, so let's see. Question 9.2. It says the following. There's a chord MN. I stop reading, QN rather. I stop reading immediately. What does it mean for something to be a chord? It means it is straight. A chord is a straight object that runs from one side of a circle to the opposite side where it carries its name then as QN. Okay, so they say that chord, sorry, why is that important is what I wanted to talk about. Because you have got quite a few theorems where it says the radius is perpendicular to the tangent, okay? Or the radius bisects the chord, or the chord subtends angles on the circumference. So these words are key words for you to start filling in things on your diagram. Let's read on. It says the chord bisects the angle MNP. We stop reading. We go to MNP and we indicate that that angle there is bisected by bringing in a symbol. So let's put that symbol down for the fact that those two angles, and it's just for, clarity, show a one-liner that runs through it. Okay, then they say it intersects the chord. There's another chord, MP, at S. Now remember, guys, the word intersect in geometry means they cross one another. Okay, so my fingers are intersecting here at that point where they cross one another. That's the point of intersection. Okay, so they also told us it's a chord. Let's see why that was important. They said MP over here is also a chord, and it's intersected by this chord at S. Now that is key knowledge for us to have, folks, because for us to talk about MP as a chord means it is straight. It's a straight geometric object. So we're going to look for, if two chords intersect, the vertically opposite angles that are equal. One of these chords I see, we haven't read it yet, but we're getting to that point where we're going to read that there's parallel lines. And if you have parallel lines, the line that crosses them have to be straight. It has to be a line that is, by definition, straight. Okay, let's read on. Intersecting at S. If I want to, I'm just going to put two dots there and maybe a cross there to show and remind me that these angles, let's put two dots because of that dot at the center. This is equal to that vertically opposite. Those two are equal vertically opposite. That's all we can say so far. Now look at this. The tangent at P. So at P, there's a tangent. Now that tangent clearly is this line over here. Okay, I stop in my tracks and I've read the word tangent. Now remember, 3 theorems on tangents. The tan-chord theorem is one of them, the radius being perpendicular to the tangent. And if there's 2 tangents from the same point outside of the circle, then those 2 tangents will be equal. Those are our 3 tangent theorems. Let's see which ones are here. If this is the tangent line over here, the angle between the tangent and the chord, let me use a green, that angle is equal to the angle in the alternate segment. Now here's the chord. The angle between the chord and the tangent is equal to the angle in the alternate segment. So M2, let's give it 2 lines, is equal to P1. So both of these angles are X. Okay, let's see, is there a radius? No, there isn't, because we were not given the center of the circle. There's also no other tangent that runs to the circle. What we can, however, say additionally is that this full angle over here, and I'm going to make it a blue dotted angle. There's the tangent, here's the chord. Okay, there's the chord MP. It's equal to the angle in the alternate segment. So P1 plus P2 is equal to Q1 plus Q2. And you'll see just now why that is going to become important. Okay, then we go back and it says it meets MN produced. I stop reading. Listen carefully, matrix. If I tell you a chord has been produced, it means that this whole object is straight. Okay? So if I tell you something is produced, MNP, you have something that is straight. If it goes over the circle, if the reason that we're telling you it's straight means there's exterior angles going to come into play later. And those are the theorems that you forget, because the easiest one you learned was when you were in grade 9 or 10, when you learned about the exterior angle of a triangle. Don't forget that one. Okay, let's read on. It is produced to R. Okay, so they told us that that line, that is indeed a straight line from M to R we have a straight line. Okay, we'll come back to why that is important in a second. Okay, so it says it meets it at R, such that, and this is what I was burning to read, we could see that they were parallel because it was filled in on the diagram. But we have to read it as well. So here, this line is parallel to that line, which is now going to make this diagram look like a circus when I start working on it. Let's see. I go, first of all, I'm going to turn everything orange. I have a line here, QN, that is parallel to RP. If you look carefully, RP, QN parallel. So this angle here is equal to that one over there. Angle P1 equals N1. Why is that the case? They are alternate angles. So I'm going to turn this one into a one-liner, or let me turn this one rather. Let's leave that one. Let me just undo that line. And let's turn this one into the yellow angle, a yellow one-liner. But now look at the beauty here. By the tan chord theorem that we applied, this now also becomes a two-liner. So this is X, this is X, that is X, and so is that on my diagram. So far. Okay, I can also see that here's a line, RP is the chord, SN is a part of a chord, but it's parallel to that one. So if I collect my blue pen, those two angles are indeed equal. Okay, folks, now we go over to phase 2. We finished with phase 1. Phase 1 dealt with the information that they gave me. Now I'm going to look for hidden information. Okay, you're going to see what I mean by that now. So the first hidden information is there a cyclic quad? Let's have a look. Well, if I look at the picture here, definitely. A cyclic quad is defined by 4 points that lie on the circle. So let's collect the blue. The exterior angle, remember I said exterior angle because they told you the line is produced, is equal to the interior opposite. So those two angles are definitely equal to one another, exterior angle of that cyclic quad. This little angle is not an exterior angle because it's not formed by a side that has been produced. Okay, what else can I say? Let me collect the orange. I've got the cyclic quad. Now look at this, folks. Here, I've got another one of those. Angles in the same segment, another X. Here, angles in the same segment, another X. All of this happened the moment these lines became parallel. This is what happened to our diagram. Okay, we hit the parallel lines. Now everything all of a sudden changes their relationships. Let's see if there's more that we forgot about. Yes, there's one. Look here at PQ. At PQ, it subtends the X at the top. So at PQ, it will subtend the X over here as well. Okay, so that is insofar my angles in same segments are concerned. And then I can say that this angle here at Q1 is equal to the angle at P2 for the same reason subtended by the chord MN. Okay, I think we have an enormous amount of information on our diagram. Let's see, what does the first question want us to answer? And that's on my next page. The first question says, determine the following angles in terms of X. So we're working with angles in terms of X. Please, guys, notice the mark allocation. So I've got N2 that I want to find, and here determine the following angle. Also in terms of X is a Q2. Okay, so let's have a look. A and B. Number N2. Let's go back. Let's see where number N2 was. Well, N2 was this angle. And remember, that's where everything happened. The lines became parallel, hence my angle that was between the tangent and the chord became equal to the alternate angle on the other side. That's how it happened. So let's see how we write down the reasoning, and this is the important step. P1, or we can start by saying the two lines are parallel, and then that P1 was equal to N2. Okay, so the two lines that were given as parallel was Sn, or rather Qn, whichever one you want to choose. Qn is parallel to PR. That was part of the given, and based on that, given to us, we can say P1, which is equal to X given, is now also equal to that N2. And the reason for that was tan chord theorem. So we've got our 2 marks in P1 and 2 was equal. They're both equal to X. That was given. Remember, this is the component that was given. This became equal to, it's not the tan chord theorem. Let me just remove that. It's because the lines were parallel, so it is alternate angles that are equal. So alternate angles equal, and you're basing it on the fact that those two lines are indeed parallel. Okay, so we're going to use the tan chord just now. Let's go back. We want to see where Q2 is. Q2 is down here at the bottom. Okay, here is our Q2 that we need to relate. Now, how did this become an X? Well, let's see. P1 became equal to M2, the tangent chord theorem. So that's our first statement. P1 equals M2, and then M2 will equal Q2 because of the angle in the same segment. So let us write that down quite nicely on my next page. Let me go and get the arrow. Okay, let's rather use the mouse. It seems that my pen, there's it, my pen is going on strike. Okay, so let's write out what we just said we saw. Remember, it started with the tan chord theorem. So first of all, P1, angle P1, was equal to angle M2, and they both are equal to X, and that was because of the tan chord theorem. The very next statement we're going to make is that M2 was equal to Q2, which is the one that we wanted, which is also then equal to X. And the reason for that is angles in the same segment. So we're acknowledging two things. We're acknowledging where it's starting, and we acknowledge what happened after that in part B. Let's see what they want us to show in part C. And this is where the matric work comes in, folks. It is a 6-mark question. They're asking us to prove, giving reasons, that Mn over Nr is equal to Ms over Sq. Now let's see where that lies. Mn, let me just get, let's use the blue over here. There's Mn. I want that over Nr. There. They say, prove giving reasons that this is the case, that Mn over Nr is equal to Nr, which lies, Ms rather, which lies over here, over Sq, which lies over there. Now that looks strange. That looks very, very strange, because we know if things are parallel like they are, then Mn over Nr, our theorem tells us that mn over nr is equal to ms over sp. That's what the theorem says. And our reason is our sides are in proportion because our lines are parallel. So we're calling on the proportionality theorem that we learned in grade 12. Okay, but let's see what changed. If I look at where SP is, or SQ, it lies here, and SP, the other line, is actually there. But what do I know? I know that this angle P3 is equal to angle Q2. Now, I can't just go and say that P3 is equal to Q2 is equal to X. I need to reason how that happened. That's where the marks come in. So we need to think about how did P3 enter the picture. So let's see. If I look at where P3 is down here. P3 was equal to N1 that lies up there. Okay, and that N1 and P3, those two being equal. Oh, and we forgot another one. There's a R over here that's also equal to the N1. So we could possibly try and use those. Okay, so let's see. Let's write out our argument. I'm going to write our argument on this page, folks, because we'll have to jump between the pages all the time to come back to the diagram so you can see what I mean. So let's start off and let's acknowledge. We've already acknowledged that the lines are given as parallel, and we've acknowledged this. Why is this the case? Why is Mn over Nr equal to Ms over Sp? Is because the sides are in proportion from our parallel lines. Okay, so now we can start constructing our argument. N2 was equal to P1. Angle N2 was equal to P1, which is equal to X. We had that above. We don't have to state that reason again. But what did we learn right in the beginning? We learned that this angle was bisected. And there's our link. This angle was cut in half by the chord QN. They told us right in the beginning, they said QN bisects the angle MNP. So we're going to say but here at this point. N1 equals N2 is equal to X. And that was just given to us right from the beginning. We're putting it equal to X because N2 comes into this picture as well. Okay, so that's our second step. So what can we make from that? We can say also that N1 here, N1 up there, is indeed equal to angle P3. And that makes it equal to X. And why is that so? Angles in same segment. Now remember, we're wanting to prove that these two things are equal. That's where all this reasoning is supposed to go. So we want to end up with something that says that Q2 is equal to P3. Okay? We need to bring in that argument. So let's see, are we ready to say that? What is Q2 equal to? Okay, so we've had Q2 was equal to M2. Is it in any way equal to something that lies over there? This was a tan chord equal. That is same segment equal. So we can go from M2, which was equal to P1, and we can say also that P1 is equal to M2, and that is equal to X. Okay, and this here was proven already by the tan chord. So this was above, and then therefore M2 is equal to Q2. Okay, now remember, that comes from also our argument that we had in our previous case. So we can now state that P3, angle P3, is equal to angle Q2. Okay, we've got those two angles equal and can then say now that SP is indeed equal to SQ. Why is that the case? Those are sides that lie opposite equal angles. And because those sides lie opposite those equal angles there, they are indeed equal. So we can now go and replace the SP in here with the SQ. And that is what they wanted us to prove. So we can finally conclude that MN over NR is equal to MS, which is what we had, over the SQ. Quite a long problem. It was there for 6 marks, folks. So you have to remember how your matric theorems and your grade 11 theorems sort of intersect in problems like this. There's not a grade 11 question separate from a grade 12 question. All the geometry comes together in a particular problem like this. Okay, we're going to take a short break and then we'll be back with you again.
Did you know that scorpion venom is the most expensive liquid on Earth? Scorpion venom costs around $10,300,000 US per liter. The protein found in scorpion venom can be used to treat pain in humans who suffer from multiple sclerosis, inflammatory bowel disease, and rheumatoid arthritis. Only 25 species of scorpion have venom that would be lethal to humans.
Welcome back to Tenfold Live, proudly brought to you by Liberty, our sponsors. Thank you so much for making all of this possible. They also bring you the Tenfold education app, the one that I told you about in the beginning of the show. Yes, tell your friends to download it. Tell their friends to download it. It is packed, guys. It is packed with content to help you ace all of those questions. You can also connect with us on WhatsApp. You can just send through a text or send through a picture of the question that you have, and we will answer all those questions. And if you feel like streaming, you can stream on YouTube. We are Mindset Learn. It is Mindset Learn. So ask all those questions, and let's ace all of those questions and all those exams. Over to you, Jock.
Thank you so much, Piwe. Okay, folks, we're on our last geometry question, which was a little bit of a challenging one, I would say. Sorry, I'm on the wrong geometry question there. Let me go back one. There we go. There is our question. It was a little bit tricky. It's question 10. So let's see the reasoning that they give us and how do we fill that into the diagram before we even start to consider what to do. So I'm going to use a nice bright color this time. In the diagram, the circle passes through 3 points, DBE. Okay? There. So it means that those points lie on the circumference of a circle. So if we need it for some reason, folks, then we have it. We've got this as a chord because it runs from there to there, and we somehow need to read that something was produced before we can believe that this is a line is straight, or that will be, we need to read that as a chord. Okay, let's see. The diameter ED, oh, here they surprise us. The diameter is given. The moment the diameter is given, remember what comes to your mind? If there's a tangent, those two things are perpendicular. Does the diameter subtend an angle on the circumference? And yes, it does. So what we get, the takeaway from that one, is that here at B2, we indeed have a right angle. Now, I hope your eye caught it. My eye immediately caught the right angle that they gave us there. So if this here is going to be a produced line, then immediately, folks, we have a cyclic quad over here, because the opposite angles are 180 together, or you can then argue the exterior angle is equal to the interior opposite over here. Okay, so let's read on. With this as a diameter, it is produced to C. Look at that. The diameter is produced. So this is straight. Okay? AC is a tangent to the circle. So yeah, that's as much as we can say there. So, but we can now immediately claim this as a cyclic quad, which will then make this angle here at F1, folks, the angle at F1 equal to the angle here at D2, because this is also an exterior angle to that cyclic quad over here. Okay, I haven't read that this is a chord so far, which means that it's straight, but I'm going to show you where they give us that information. They give us this as a chord BE. So immediately I could say that as well. Okay, and then obviously there's a little bit more. There's this angle that's external here, and interior opposite related to F2. So all of that comes from the fact that they gave us that line is indeed produced. Okay, so far that's what we've got. We said we've read that this is a line or a chord over there, so we'll come back to that. Okay, and AC is a tangent to the circle at B. So AC, I'm looking for the point A, it's hidden down here. AC is a tangent to the circle at point B. So the angle between, let's collect the yellow, the angle between the tangent and the chord is equal to the angle in the alternate segment. So this is a yellow one-liner. But also over here, we have a chord DB. Here we have the tangent, so that the angle between the tangent and the chord at B1 is therefore then equal to the angle at E. Look carefully, follow my fingers. There's the chord. Okay, the angle in the alternate segment is the one that lies on the circumference on the opposite side. So follow again. There's the chord, okay? The angle that lies between the tangent and the chord is the two-liner, and then we follow until we meet on the circle, and that will be a two-liner as well. Okay, so that is, I think, so far everything we can take from the tangent. Yes. Yes, it looks like that is it. Let's read on. M is a point on DE such that AM is perpendicular to DE. Ha, there they confirm that we didn't see this incorrectly, that this is definitely a right angle. Okay, AM, now AM is this line. Now the moment they name something like they did over here, folks, then you can immediately accept it as straight, AM, because they didn't say curve or whatever there. It's a line segment, AM, and chord BE intersect at F. Now at this point, I had the fullest right to start making angles equal, once I've read this and that. Okay, so I can say immediately that this is vertically opposite equal to that. And if we grab the blue, then these two over here are also vertically opposite, equal to one another. Okay, now let's see, are there any hidden information that they were supposed to, or didn't tell us, that we're supposed to get from this diagram? I don't think so. If I look at, we had tan chord, we had that, we had this. Yes. No, we're ready to go to our first question. Now, our first question says the following. FD, oh, look at this. This happened right in the beginning. They're asking us to prove the cyclic quad that we found literally after having put into place in this diagram the first 3 or 4 angles that are equal to each other. We've got it. The answer's in the diagram. Now, folks, that's a key thing I just said. I said the answer is in the diagram. If you did a good enough job of analyzing that paragraph, the answer will be in the picture. Okay, the answer will be there, and you'll have to do the mental gymnastics to try and remember how it happened. So let's go back. FDM, the cyclic quad. It happened almost immediately after. In fact, it happened after, because that was there right in the beginning. So it happened when we read that this here is a diameter. This became a right angle, therefore exterior angle equals interior opposite, and it is a cyclic quadrilateral. So let's write that down as an argument for 3 marks. We'll start off and we'll say that M2, angle M2, is a right angle. And that was the angle that they gave us right in the beginning. Okay? And then that is now for our cyclic quad. M2, let's remind you, M2 is that angle over there. B2 became a right angle when we read about the diameter. So B2 also, you can use the word also, angle B2 is equal to 90. And the reason is it's an angle in a semicircle. And that's enough for us. Therefore, M2 is equal to angle B. Why? Because they both equal 90 degrees, just to remind you. And what can we say? Therefore, the exterior, or let's go FBDM, is a cyclic quad. And the reason is the exterior angle is equal to the opposite interior angle of the quadrilateral. That's how it became a cyclic quad. And remember, after that, there was a lot of things that became equal to one another, or there were 2 or 3 more things that happened after that thing became a cyclic quad. Let's read on. Prove that by giving reasons that B3 is equal to F1, and please note that this is for 4 marks. Now B3 is here, is equal to F1 that lies over there. Now, folks, we have to absolutely think how that happened. Well, this became a cyclic quadrilateral, okay? So this angle became equal to D2, okay, because of exterior angle of a cyclic quad. And B3 became equal to D2 because of the tan chord theorem. Okay, so it's asking us to argue the case that B3 is thus equal to F1. So let's write it out. B3 is the angle between the tangent and the chord. Let's start with that. B3 is equal to, what was it, D2. And that was the tan chord theorem. Okay, that was the first thing. But then also we had F1, which was equal to D2. And that was because of the exterior angle of the cyclic quad. CQ stands for that cyclic quad. Now remember, it's for 4 marks. Okay, we almost have deserved all our marks. We just need to conclude here, therefore, that B3 is therefore indeed equal to F1. And that's what they wanted us to prove. So we used the tan chord theorem to get there, and we used the fact that there was an exterior angle to the cyclic quad. We did well so far, I think, for 4 marks. Okay, let's see what is next on the menu in terms of questions. Oopsie, for 3 marks. 3 marks, they're going to ask us to prove that the triangle, now let's go back to the diagram. We're looking at triangle CBE over here being similar to triangle CDB. So C, let me label it so that we can see that it's different. Let's go orange. CD, rather, B, that one here, the small one, okay? We want similar to CBE, the big one. So I'm just going to put a circle around this so that you can see where we're looking at. And we're looking at that big triangle. So the first thing that your eye should tell you here is that you have 2 angles that are equal. B1 was tan chord equal to E in the other triangle. So we've got that angle. And C is a shared angle. How easy was that? Okay, let's have a look. Let's write this out. This is in the small triangle. B1 is equal to E. In the bigger triangle, okay, because of tan chord. And then because the angle C belongs to both those triangles, that's our job done. So for 3 marks, let's write out our proof of that this is definitely the case over there. Okay, so we started off and we're going to say that B1 is equal to E. That's where it started. Angle B1 equals angle E, and that was the tan chord theorem right in the beginning. Tan chord theorem. Angle C is a shared angle, okay, in the triangles. So we can immediately say, therefore, the remaining angle has to be equal over here. Okay, so in here, over here, it's this angle D there, which is equal to angle, we've used C and E in the big one, which will be equal to the angle B there. But we can immediately say that triangle CDB, the full triangle, is indeed similar. Now remember, similarity is with 3 vertical bars, is equal to the triangle CBE. And the reason they are equiangular. You don't have to state the third angle because you know that the sum of the angles in these 2 triangles is 180. So nothing is going to change. Okay, let's see what the next section says, the next 10.2. If it is further given that CD is 2 units, DE is 6 units, calculate the length of BC. So let's go back to our diagram. CD is 2, DE is 6. DE is 6 here. From there to there is 6. And they told us that CD, which is this part here, is 2. Now, you can see that these things lie across triangles. So CD only belongs here, and CE belongs to the whole big triangle. So the CE component is going to give us that length in the big triangle. Okay, so let's go back to what they want us to prove. Okay, they're saying to us, with that in mind, CD, now I'm going to just copy this over here, that the triangle CDB was similar to triangle CBE. So we can write down our ratios. Okay, so the first thing we know is that they told us that CD is definitely 2. Okay, we saw that CE is 8. Okay, so folks, you can see which sides you're supposed to use. You're now supposed to use CB and also CB over here. So there's a CB there that you've got to use, and there's a CB over there. So we can state our, and that's what they want us to find. They want us to find BC, okay, which the other way around is CB. Okay, so let's write down the ratio. CB over CD. CB over CD is definitely equal to, where's it, CB? CE over CB. And the reason for that, again, is the sides are in proportion. Okay? So if I want to find BC, then I just need to cross multiply. So BC squared will equal CD, which was given as 2, multiplied by CE, which was given as 8. So that gives us 16, which leaves us with BC as 4. Now, folks, that is definitely for 3 marks. That's 3 marks worth of work, and it's easy. You work with the ratio that you've just proven. You put your values into that ratio, and then you see the sides that you're supposed to use. Now, remember, I just found out that CB is 4. So let's put it in the diagram here as well. There's a 4, and there's a 4. The CBs are 4 each. Okay, so let's go to 10.2.2. Now look at how nice they are to us here. They want us in 10.2.2 to find the length of DB. Now if you look at DB, let's use green. I hope this one is green. Yeah, there's DB. Okay, so we're now supposed to use other ratios. If I go back to my diagram quickly, let's just quickly go back there and have a look. We found that CB is 4. So this here is 4. That is 2. Remember, this whole side there was 8. And they're now finding or asking us to find this length over here. Okay, so that corresponds, that length over there. If you look at the triangle ratio, DB corresponds to, where is it here? DB corresponds to the BE in the previous triangle. Now let's just see where BE lies. BE lies from here to here. Okay, and we can see it also lies in a right-angled triangle, interestingly. So if we can find BE in terms of the other numbers, we might just need to then move into right angles. Okay, so we're going to need this information up there. Okay, so if I start this is also 4 marks. So it shouldn't be rocket science. Let's start with something that we know now that we need. Now remember we said we want to use dB over there. So CD, we're going to use CD and BC to start. No, we're not going to start with that. Sorry, we're going to use BE and DB. So you can use DB and CD or DB and this CB over here, because you've got those values. So you're really spoiled for choice over here. So while I've got this little space at the bottom, let's write down the ratio we'll be using. So let's go for BD, here, that one, over DC, which is the small one, over DC, is equal to BE over CB, or BC. Okay, we can write those values in, and the reason here is the sides, again, are in proportion because these two triangles are indeed similar to one another. Now, folks, this is really and truly where you've got to concentrate so that you don't make a silly error, because the question is not difficult. The question is actually very easy. You've got these numbers, you've got the ratios, plug them in, play with them, see where this goes. Okay, so let's do exactly just that. If I put my numbers in, remember I'm looking for BD, and BD is up here. So I can say that BD will then equal BE multiplied by DC over BC. I'm simply just manipulating the figures. So BE I still don't have, but I do have DC and I have CB. So what does this tell me? It tells me, if I carry on this side, that a half of BE is equal to BD. So let's write it in a better way. BE is twice the length of BD, whichever one of the two you want to use. So we've gone through the first part of this. Now let's just see what is the implication on our diagram. And I'm sure you all will agree with me that this BE over here, the line segment BE, there, is the one that we are going to use in terms of dB in this right-angled triangle. So we're going to run to good old Pythagoras to answer that question. Okay, so let's continue and finish this one. We have now that in that right-angled triangle, now you can just put the word now if you want to, BD squared is equal to BE squared, or plus BE squared rather, because these are the two right-angled sides that we had, is equal to 36. Now, where does the 36 come from? Let's just remind you. It's the length of DE that is indeed squared. Okay? So if DE is squared, we get the 36. But we also know from our work here that BE is twice BD. So we're going to try and avoid the fractions. This, is Pythagoras. Remember, we've already stated that one of the angles is a right angle because it's angle in a semicircle. We've done that right at the beginning, so you don't have to justify the 90 degrees again. You did it in the beginning, okay? It's based on the diameter that was given. Okay, BD squared plus, now here, 2BD, all squared is 36. If I now do the algebra, I get BD squared plus, what is this? This is 4BD squared, which is equal to 36. Now at this point, folks, always think that they made a mistake, because you sort of expect to having to be able to square root the 36 and to end with a nice number, which is not going to be the case, the case over here, because we've got a 5BD Okay, so let's get that by itself. BD squared is equal to 36 over 5, and then we get to BD, which is then 6 over the root of 5. So there was a lot of algebra. All of this here was just simple geometry and algebra mixed with one another that we had to complete to be able to find that side. But the important part to this whole question, and to discuss that, I want to go back to the beginning component here, this diagram over here. The important thing that happened, or that we have to do in these diagrams, are this little treasure map, filling out all of these little cues that I read when I start with the wording of the question. So this paragraph here at the top of the page is the most important part of a geometry sum. Just look at what they could have still asked us over here, folks. They could have asked us to show that AF is a tangent to some other circle here. Why? Because these two lines became equal. Why did they become equal? Because those two base angles became equal. Why did that happen? Vertically opposite the exterior angle to cyclic, quad and tan chord. That combination made these two angles equal to each other. So they could have had a third part where they said show that AF is equal to AB. Okay, the big thing for BE here was the fact that we had that it's twice the length of BD. Then we could easily go and grab something as ancient as Pythagoras' theorem to work out what it is that we are asked to do here. Now, folks, that's your geometry. Remember, geometry relies on you knowing your theorems, not like a parrot. When you learn your theorems, put them on paper, draw the diagram while you're learning. Something like the tan chord, and I'm going to finish with this. There's a circle, there's a tangency point, there's the tangent, there's the chord, is equal, there's the angle between the two, is equal to the angle in the alternate segment, which is this one over here. Okay, so while you say the theorem, draw the condition on paper so that you form these mental pictures in your head and you can identify them in your diagram. Okay, folks, and that's unfortunately all we have time for this week. So from my side and from the fabulous crew here in the studio, it's until Monday next week and Thursday when we see you again. Ciao.
peeps, welcome to Moby School. We are here to make sure that you, yes, you get all the marks that you deserve on the go. We're here every Mondays to Fridays from 2 to 3 p.m. only on Mindset Learn TV. Now, this is a whole hour worth of revision just for you. And I hope that you've got your notepads and your pens ready and that you and your study group are game for today's revision session. Now, my name is Joe, and just like you, I'm also matric, and I'm here for a whole hour to make sure that I ace my final exams, and I hope that you will be doing the exact same thing. Now, do remember that we love hearing from you guys, so log on to our Facebook page, which is www.facebook.com/MobySchoolSA. Drop us your comments, like our page, share the page, and even spread the Moby School family even bigger. Now, isn't that cool? Yep, yes it is. Now, do remember that you can catch